Today we are starting 4.3. What we're going to be talking about is equivalent fractions. What does that big word equivalent look like or sound like? Equal, okay? So when we're talking about equivalent fractions, we are talking about equal fractions, okay? Go ahead and write these tips down. These tips will help you for our lesson today. Okay, let's talk about some of these tips that you just wrote down. First of all, to write equivalent fractions, I've given you a couple steps of things that you can do. First, you can multiply or you can divide, but you must make sure every time that you are multiplying or dividing the numerator and the denominator by the what? Same number, no matter what, okay? So let's just talk about, let's say I had 3/3. Do you guys know if I reduce 3/3, what does that equal? 1 whole, okay? So if I am multiplying or dividing by 3/3, I'm going to get the same exact answer because I'm just multiplying or dividing by the number 1, okay? What about 5/5? What does that equal? 1, okay? So once again, just make sure that your numerator and your denominator are being multiplied or divided by the same number, and you're going to be able to get an equivalent fraction or an equal fraction. Read me what the second tip says. All right, so division is not going to work if the fraction is already in simplest form. Just think about this. 1/2. Can I divide that by anything on top and bottom? No. Aside from the number 1, I cannot, okay? So if it's already in simplest form, you're not going to divide. Instead, you would just multiply. All right, so I'm going to go through a few examples so that this makes a little bit more sense. Number 1. Write 2 fractions that are equivalent to the given fraction. So one thing I want you to look at carefully, this says to write 2 fractions, not just one, but 2 fractions that are equivalent or equal, okay? So my first tip said that I can write equivalent fractions by multiplying or dividing the numerator and the denominator by the same exact number. What number can I divide the numerator and denominator with, Michael? A 2. So this is how you're going to show me that work. Divided by 2 on top and 2 on bottom. Because if you remember, when we talk about 2 halves, that equals 1 whole. So I am just dividing by the number 1. When I divide by 2 on top and 2 on bottom, what do I get, guys? 3/4. Am I finished with problem A? Yes. Incorrect. Reread me the instructions.
2 fractions.
Right, 2 fractions, okay? So here's what we're going to do. We're going to go ahead and rewrite this first original fraction that we had, 6/8. Now, I had told you that you could multiply or divide by the same number on top and on bottom. So let's go ahead and multiply. You can multiply by any number that you want on top as long as it's the same number on bottom. So who has one that you want us to multiply it by? Katie.
3.
All right, she says times 3. When I do it, I'm going to multiply times 3 on top and 3 on bottom. Because, guys, what does 3/3 equal?
1.
1. So I'm just multiplying by the number 1. If I multiply this out, what do I get? 18/24. That means that fraction is equivalent to 6/8. So we're going to go ahead and box this one in and box this one in. Now, you could have done any number in there, all right? I could have also taken 6/8 and multiplied times 2 on top times 2 on bottom and gotten 12/16. I could have taken it and done 6/8 times 4 on top times 4 on bottom and got in 24/32. Once again for this, I said I only needed you to give me 2 fractions, okay? But you can multiply by any number or divide by any number if it goes evenly into the numerator and the denominator. So let's go ahead and try problem B on our own. Can anyone find a number that I can divide into a 95 and also into 126? All right, so he guessed a 6. Guys, what's 95 divided by 6? Okay, it doesn't equal a whole number, so 6 is not correct. Who can think of another one? What do you think? She says 4. Everybody plug it in. What's 95 divided by 4?
24.
Okay, so that does work, 24. What about on bottom? Divide by 4.
31.5.
31.5. Is that a whole number?
No.
No, so dividing by 4 is not working out. How about if we instead just multiply? Because I don't care if you divide or if you multiply. What's a tiny number I could multiply by on top and bottom? A 2. Let's go ahead and just start with a 2. If I multiply by 2 on top, I've got to also multiply by 2 on the bottom to get an equivalent fraction. Remember, this means the numerator and the denominator ratio is still exactly the same. I'm just multiplying it by the number 1. What's my new equivalent fraction? 190 over 252. Am I finished with problem B? Why not?
You have to add 2.
I need 2 equivalent fractions, so I want you guys to go ahead and come up with another one on your own. All right, who can tell me one that you did? Michael, what'd you do?
380 over 504.
Okay, how did you get that?
And multiply numerator and denominator by 4.
Okay, so we're going to just restart with our original fraction that we had. He multiplied times 4 on top and 4 on bottom. And what did you say you got? 380 over 504. Okay, who got a different one? Jakari, what'd you do? Okay, so what did you multiply the top and bottom by?
6.
He multiplied by 6 on top and 6 on bottom. Did anybody do the number 3? Okay, what'd you get if you did number 3?
285 over 378.
Excellent. So when it comes to this kind of thing, whether it's homework, quiz, review sheet, test, as long as you make sure it's equivalent, I will accept any answers. So go ahead and box those answers in because those are the 2 equivalent fractions. Number 2 has given us different instructions. It says to write the fraction in simplest form. A word that you've probably heard of before is to reduce it, okay? In red, you wrote down divide the top and the bottom number by the same exact number. So it's very similar to what we just did. So let's look at the first one, 8 28ths. What number can go into 8 that can also go into 28? Landon.
2.
All right, he says number 2. So I'm going to divide by 2 on top and 2 on bottom. Landon, when you do that, what do you get?
I meant to say 4.
He meant to say 4. All right, we'll go back to that here in just a minute, okay? Because 4 would have been the best option, but I'm going to show you this is okay if you do it this way, okay? When you do this, what do you get, Landon? 14, okay? So now he's saying he wished he had started with a 4, which is totally fine. 4 would have been a better option because if you look at this, those are both even numbers. So I know I could divide by 2 again, all right? So I divide by 2 on top, and I divide by 2 on bottom. Landon, when you do that, what do you get this time? 2 sevenths, okay? So here's what he was saying. Instead, he divided by 2, and then he divided by 2 again. If I were to multiply these two numbers together, 2 times 2 is 4, that would tell me a 4 could have gone into that. So instead, what I should have done was 8 28ths divided by 4. Guys, what's 8 divided by 4? 2. What's 28 divided by 4? 7. Okay, so do you see, no matter what, I got the same answer, but if I had done it this way, that way was a little bit easier because you don't have to divide as many times, okay? But I do not care how you get the answer. As long as you get 2 sevenths, I am totally fine with that, all right? Let's go to the next one. Let's go on to problem B. 12 16ths. Kyla, what number can go into 12 that can also go into 16?
2.
Okay, there's something bigger than a 2.
4.
A 4. Let's try a 4. All right. Remember, whatever you divide by on the top, you've got to divide by on the bottom because that's basically just saying 4/4 or 1 whole. All right. What is 12 16ths in simplest form?
3/4.
3/4. Can 3/4 get any smaller? No, there's no other number that goes into 3 that can also go into 4. Let's go to the next one. Skip a line and go ahead and write down C and D. Problem C says 8 15ths. What number can go into an 8 that can also go into a 15?
Nothing.
No numbers, okay? There is not a single one that would be in common. So this is actually one of the easiest problems ever because all you have to do is just put a box around the original problem without showing any work because 8 15ths is as simplest form as it's going to ever come, all right? I want you to look at the next one, 7 28ths. What can go into a 7 that can also go into a 28?
7.
A 7, okay? A lot of times it's a great idea just to check that numerator to see if the numerator, because we know it can go into itself, can go into the denominator. So we're going to divide by 7 sevenths, which is the same thing as the number 1. And what is our equivalent fraction?
1/7. 1/4.
1/4, because 28 divided by 7 is 4. All right, so this is how you put something into simplest form. Now, when you come to a test or a quiz, I want to see this part right here, because that shows me you understand how you got that answer. Problem number 3 is given us a new set of instructions. It says to write the fractions in simplest form, which is very similar to what we just did, and then tell whether or not they are equivalent. So what we're going to do is we're going to go ahead and rewrite these original fractions, and then we're going to put them in simplest form. Okay, so the first thing we've got to do, if it's in simplest form, should I be dividing or multiplying? We're going to divide it because we want it to be as small as possible. What number can go into a 45 that can also go into a 54? The number 9 is correct. That is the biggest number that they both share in common. When I divide by 9/9, it's like I'm dividing by 1 whole. What's the answer?
5/6.
5/6. Now, I am trying to figure out if this right here is equivalent to 8/18. The only way I can figure that out is if they both equal the same exact fraction whenever they are in simplest form. Let's figure out how to put 8/18 into the simplest form. What number goes into 8 that also goes into 18?
2.
The number 2, not a 4. A 4 can go into an 8, but a 4 cannot go into an 18. So we've got to divide by 2 on top and 2 on bottom. When you do that, Carlos, what do you get?
4.
Not 4/6,
4.
4/9. All right, so right now, this is my answer that I've got for putting them in simplest form. If I look at that, is 5/6 the same exact numbers as 4/9? Yes or no?
No.
No, it is not. So underneath that, you're simply going to write no. This tells us that no, they are not equivalent. They don't equal the same exact thing. Let's do one more example like this. I've got 1/3 and 4/12. Just like we did before, we're going to go ahead and rewrite the original problem. What number can go into 1 that can also go into a 3?
Nothing.
There isn't anything. So what does that tell me about 1/3?
Box it in.
Just box it in. It's already in simplest form, so there's nothing else that we need to do for that, okay? And here's a clue. If ever you have the number 1 in the numerator, you're done. That's as simple as it's going to get. Let's go to the next one. 4/12. What number can go into 4 that can also go into 12? A 2 or a 4, but which one's bigger?
4.
In order to get as simple as possible, you always want to get the biggest number that the two share in common. When you reduce that, what do you get? 1/3. Does 1/3 equal 1/3?
Yes.
Yes, so the answer is yes, these two are equivalent fractions. Our review problem today is from yesterday's lesson. Yesterday we started talking about finding the GCF. What does GCF stand for? Greatest common factor. So go ahead and write this down in your notes for number 4. We're going to be trying to find the greatest common factor using prime factorization. So you guys did prime factorization yesterday on your homework. What does prime factorization mean?
Upside down division.
Upside down division. So we are going to go ahead and do upside down division with these two numbers. Who'd like to do the number 12 for me? Jakari. What should I divide by?
2.
And what do I get?
6.
Divide by?
2.
And what do I get?
3.
Divide by?
Can't divide.
You don't need to divide by anything else because the number 3 is prime, so that tells me that we're finished. Let's go on to the number 18. Who wants to do 18 for me? Kyla.
Divide by 2.
What do you get?
9.
Good job. Keep going.
Divide by 3.
Very good.
And at least a 3. And that's it.
And that is it. Very good. So now if you remember, we've got to list our factors in order from least to greatest. After we've put them in order from least to greatest, does anybody remember what I need to do? Emma. Circle the pairs. Emma, help me out. What are my pairs?
2 and 2.
The first one is 2 and 2. And 3 and 3. All right, am I finished? No. If you remember from yesterday, these two, think of them like they were both single, they got married, the two people become one family. So just like that, for here, the two twos become what? 1, 2. And then I have to multiply it by, what do the two threes become? 1, 3. What is 2 times 3? 6. So what you guys just discovered is that your GCF equals 6. That means the greatest common factor, the greatest number that can fit into a 12 and can fit into an 18 is 6. There's no bigger number that the two of those share. Any questions on that? Okay. Now, yesterday we talked about another way to find the GCF. Do you guys remember what that was called?
Yes.
What was it?
It was relative.
Listing factors, okay? Listen, you're finding the same thing. What I've asked you to do here is I said to find the GCF, okay? So what two numbers did we just find the GCF of? 12 and 18. Guess what we're going to do on the next one? I want you just to skip a line and write this down. We are still going to be finding the GCF just like we just did, but this time we're going to do it by what? Listing factors. Because I'm finding the GCF of the same two numbers, the number 12 and the number 18, my GCF should be the same number. So we're going to find out if, by listing factors and prime factorization, you can still get the same answer. All right, listing factors. What's the first factors that go into 12? Gabby?
4 times 12.
Good job. What's the next one, Asia?
3 times 6.
Very good. Kyla?
3 times 4.
Very good. Michael?
6.
6 times what?
Oh.
6 times 2. So do I need to write that?
No.
No, because I've already got it written up there. So that is it for those factors. Isabel, 18.
1 times 18.
Good job. Landon?
2 times 6.
Not 2 times 6.
2 times 9.
2 times 9. Michael? Okay, 3 times 6. Next up, Emma. You are correct. There are not any more. So what do I do now? When I'm listing factors,
I have to put these order.
put them in order from least to greatest. Okay, once you've done the 12, then you'll do the 18 directly underneath it. Alex, what should I do next? Circle the pairs. What's the first pair you see? 1. Katie, what's the next one?
2.
Jakari. Carlos. Which one? There's still another one. What is it, Michael? 6? Any more, class?
No.
No. So if you remember, when you list the factors, should I multiply all those numbers together? No. What do we say to do? Find the greatest one out of all of them. Guys, what's the greatest one there?
6.
Okay, so we found out here that GCF equals 6. Is that exactly what we got for our other answer?
Yes.
Yes. So here's what I'm trying to teach you today. Prime factorization and listing factors is just two separate ways to come up with answers. Let's think about this. 2 times 5 equals 10. Could I switch those around? Yeah, 5 times 2 equals 10. These are just two different ways that you can come up with the same exact answer of 10. That's what it is when we're finding GCF. Listing factors or prime factorization. It does not matter which way you do it unless I ask for it specifically. Either way will help you to get the GCF. Okay, so that's just a little bit review from yesterday, and that is the end of our lesson for today.